Hello guys, thanks for watching my video. Today I'd like to introduce differential calculus. Okay, then is here we deal with differential equation. Okay, so since this is the introduction, so I like to give all types of this differential equation. Okay, now let's start with the definition first. Since we are dealing with differential equation, so what is meant by differential equation? Okay, this is this differential calculus. In this we are going to talk about ODE. Okay, ordinary differential equation. Okay, ordinary differential equation, and there's also partial differential equation that we are going to discuss later. Here we are going to discuss only ordinary differential equation. Okay, let's start. So what is differential equation? So a differential equation is an equation involving independent variables. Okay, there is independent variables and then dependent variables and derivative of dependent variables. I mean dependent mean it depends on something. Okay, and that the derivative of that dependent variables with respect to independent variables. Okay, or variables. Example like dy by dx plus 2x equal to 5. Okay, here x is the independent variables. X is the independent variable and y is the dependent variables. Okay, y is dependent variable because y depend on x. Okay, so like the equation like this or like this, dy by dx whole square plus 3y square equal to 5xy. Okay, or something like x square plus 2xy plus y square times dx minus 5xy dy equal to 0. Okay, so these types of equation is what we call differential equation. Here mainly we are going to take a variables of x, y and z only. Okay, so in my next video we are going to discuss how to form this differential equation or how to solve these types of differential equation. We are going to discuss it step by step. Okay, now since we have already known the meaning of differential equation, now let's go to order. Okay, order of differential equation. In differential equation of like this we have order. Okay, so what do you mean by order here? Let's see. The order of differential equation is the order of highest derivative it constant. It derivative it content. I think this is not a constant, it will be content. Okay, the order of differential equation is the order of highest derivative it content. Derivative it content. Okay, so example like let's see order of differential equation. It says that the highest derivative. Okay, here let's see example d square y by dx square plus x square times dy by dx equal to 3. Here the highest derivative is this is derivative 1 times, this is 2 times, so here the highest derivative will be 2, right? So order is 2, right? And then d keep y by dx keep equal to constant, some constant. Here we have the highest derivative to be 3 because this we differentiate 3 times, so therefore order is 3. And again next here, do not confuse this one. Okay, d keep y by dx keep whole square minus d square y by dx square whole 4 plus xy equal to 0. Here you may say that this 2 and 4 this is bigger, right? But then it's not, we do not look at the power. Okay, we only order is nothing but the highest derivative. Okay, so here the highest derivative is this is derivative 2 times, this is derivative 3 times, so here the highest derivative will be 3, so therefore order is 3. And here the highest derivative is 1, right? and here the highest derivative is still 1 because this is one time only, right? And this also the highest derivative will be 1, I think, right? So then is what we call order of differential equation. Okay, now since we have already known the definition of differential equation, order of differential equation, now there's also another one, then is degree of differential equation. Okay, now one is the degree of differential equation, the power of the highest order derivative occurring in the differential equation after the differential equation has been free from radical and fraction of the derivative concerned. Meaning, if we have radicals like square root, cube root, right, and fraction, now after removing that radical and fraction, that the highest order, that the power of the highest order, right? Here let's see example here. Here del square y by del x square plus, not del, d square y by dx square plus x square dy by dx equal to 3. Here the highest derivative is this one, right? And here the power, the highest power will be just 1. There's nothing here, so it will be degree is 1. But if you talk about order, so here order is the highest derivative, so highest derivative will be 2, right? That means order is 2. Here if you see the order, then is the difference between order and degree. Okay, here order is 2. Now again let's take another example. d cube y by dx cube whole square minus d square y by dx square whole 4 plus xy equal to 0. Here you may consider again that this is 2, this is 4, so the highest power then is, here the highest power is 4, right? So but the degree is not 4. Why? It says that the power of the highest order derivative, right? I mean the highest derivative, the power of that highest derivative. Okay, here that even though this the power is 4, this the derivative is 2 times only. Here the derivative is 3 times, so the power is 2. So therefore here the highest derivative is this one, d cube y by dx cube, right? This is 3 times, so the highest, so the power of this one is 2, so therefore degree is 2, right? Here order, if you look at the order is 3 only. Okay, then is how we differentiate between order and degree. Okay, now let's see about solutions or primitive of differential equation. Solution, or we call it primitive. Okay, because every differential equation, something like this, have always a solution. Okay, so that solution is what we call primitive. Okay, in other words we call it primitive. So let's define what is solution or primitive. Here a function y equal to f of x is said to be a solution. Okay, now here if you find out this solution, you will get in terms of y. So since y is dependent variable, so something like y is equal to something here, right? You will get like that. So a function y equal to f of x is said to be a solution or primitive of differential equation dy by dx equal to f of x if this is the solution of this differential equation, if the differential equation is satisfied by substituting the value of dependent variable y and its derivative, right? So if you say that y equal to f of x is a solution of this differential equation, then if you substitute the value of dependent variable y, okay, y value here, if you substitute here y equal to f of x, if you substitute the value of y in here, then you will get this equation exactly. That means it's satisfied. Okay, then is what we call solution or primitive. Example, if you look at the example, you will know. Example, let's say y equal to sin x is a solution of differential equation d square y by dx square plus y equal to 0. Why? Because here it says that if you substitute the value of y in this differential equation, then this equation will be satisfied. Okay, let's see it. Since y equal to sine x, so if you differentiate one time, dy by dx, so differentiation of sine is cos, right? And then if you differentiate again, because this is highest derivative is 2, so d square y by dx square is differentiation of cos x will be negative sine x. Therefore, if you substitute here, now adding this one, if you see here, adding this one and y value here, d square y by dx square plus y equal to d square y by dx square is nothing but here negative sine x, right? And y is sine x, so negative sine x plus sine x, so which is 0, meaning it satisfies this equation. Therefore, y equal to sine x is a solution of this differential equation. So this is how we do differential equation. Okay, the solution. Now this is a solution. Now let's see about general solution. In differential equation, there's a general solution, particular solution, and many others. Okay, so let's talk about general equation. So if the solution of differential equation contain arbitrary constant, such solution is called general solution of differential equation. Okay, if you see here in the previous one solution, okay, here we get that y equal to sine x is a solution of this differential equation, but it does not contain arbitrary constant, right? Therefore this cannot be a general solution. Okay, in general solution we have to have arbitrary constant. Okay, example like y equal to sine x plus c is a solution of dy by dx equal to cos x, right? So here it contains arbitrary constant, so therefore these types of solution is what we call general solution. Now particular solution. Okay, particular solution mean when initial condition are given, right? When there is initial condition are given and the value of arbitrary constant in the solution are obtained, such solution is called particular solution. Okay, let's see example here. Here in the previous year we say that y equal to sine x plus c is a solution of this differential equation, then is dy by dx equal to cos x, right? We have to use this example here and differentiate between general solution and particular solution. So if the differential equation is dy by dx equal to cos x, where y of pi by 2 is 0. Okay, this is what we call the initial condition. The condition is given here. Then the particular solution is y equal to sine x minus 1, right? Here y equal to sine x plus 3. So since the initial condition is given here, so here the constant will be negative 1. Okay, how did we get that? Let's see here. Dy by dx equal to cos x, right? So now cross multiply them or multiply by dx, right? Now integrate it. Y equal to integration of cos x is sin x plus, since this is indefinite integral, there is a constant. So since the initial condition is given here, so y of pi by 2 is 0. So therefore if you see the initial condition, y of pi by 2 equal to here sine of pi by 2 plus the constant. Okay, this one. Okay, since y of pi by 2 is 0 here, so this is 0. Sine of pi by 2 is just 1 plus c. Now finding out the constant c, so c is negative 1. Therefore substitute here, then you will get y equal to sine x minus 1. So these types of solution is what we call the particular solution, right? Here general solution is it contain arbitrary constant, but particular solution we have to find out this arbitrary constant since the equation will have a initial condition, okay, like this. So this is the introduction part for differential equation, and we are going to deal with many differential equation in the coming video, okay. So this is just the introduction part, so that's it.